Welcome to Quality Branding Hub. The channel is for the quality control engineer, site engineer, and the civil engineer who are working in the construction field. In this channel, we are dealing with anything and everything which is required to get success in the construction. So, today, what is my topic? My topic is about the water. Water is everything for our human life as well as our construction life. That is, without the water, it's nearly impossible to do the concrete masonry work or whatever it is. So concrete is indispensable part of the construction. We cannot think of the construction without the concrete, without the water. And what is the water quality? That is determining the overall strength and durability. So we need to check very precisely and very carefully what will be the water parameter. So it is given in the IS 456. So in today's video, I will discuss each and everything about the water quality parameters requirement for the construction water. So stay tuned until the end to get the full information. And if you are new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. So without wasting time, let's jump into the subject. Now start with that why water is important. Now without water, it is not possible to do the concreting work, not possible to do the masonry work. So whenever it is involving concrete, the water is an indispensable part. Now if the why water quality is important, see, if there is any deleterious material like sulfate, if sulfate is there and water is there, the sulfate and water will react and it will deteriorate the concrete. Chlorine, that is also water required. Carbon dioxide, that is also water required to harm the concrete or as well as harm the reinforcement. So without water we cannot even think, but at the same time, if the water quality is not as per the requirement, the other harmful chemical and harmful ions will react with them and it will deteriorate the concrete strength, durability. So we need to check very carefully whenever we are doing concreting at our site. Now where we can get the water quality parameter, that is given in the IS 456 clause 5.4. In the clause 5.4 is all about the water quality. So what will be the water quality? That is given in the table in the clause 5.4 of IS 456. It is saying that potable water is generally considered satisfactory for mixing of concrete. Potable water means, that means the water we can drink, that called the potable water. So the same water should be used for the concrete, because if the water quality is not satisfactory, then our concrete strength, durability also will be in a problem, or we will compromise our durability. So that is why it is said the potable water can be used. And as a guide, the following concentrations represent the maximum permissible values. Now we need to do the water test, and water test where we can do this, that is IS 3025 part 22 and part 23. It is given that how to do the water test. So what is the requirement? To neutralize 100 ml sample of water using phenolphthalein as an indicator, it should not require more than 5 ml of 0.02 normal NaOH. Okay, so these are the requirement, and the details of test given IS 3025 part 22. So these tests you need to find out, and you need to find out this maximum 5 ml of 0.02 normal NaOH is required to neutralize 100 ml of water. Okay. Then another test you need to perform, that is to neutralize 100 ml of water using mixed indicator. It should not require more than 25 ml 0.02 normal H2SO4. The details of test given IS 3025 part 23. So these two tests are given, and these two tests has to be conducted, and the result has to be brought, that what is the requirement of the concrete water. Now the permissible limit of the solids are given in the table 1. So let's go to the table 1. What is table 1 says? See, here it is given in the table 1 that what is the requirement of the solid particle. So in the organic particle, that permissible level maxing is 200 milligram per liter. So test method is IS 3025 part 18. So organic solids, that will be maximum is 200 milligram per liter. Inorganic, test method is 3025 part 18, that is 3000 milligram per liter. And sulfate as SO3, that is part 24 of 3025 the test method, that is 400 milligram per liter. So it is the maximum limit. If it is exceed that water, we cannot use. And then chloride, the chloride is as is 3025 part 32, 200 milligram per liter for concrete not containing embedded steel. So if it is in PCC, then this water can be acceptable, but in our case maximum water is required for the RCC. So for RCC, what is the chloride percentage? That is 500 milligram per liter for reinforcement work, and suspended matter, that is 2000 milligram per liter. So these are the all tests you need to carry out whenever you are selecting water for your concrete. Now why it is required? See, here is a sulfide chloride. Now if the sulfate percentage may more, then the sulfate will start reacting with the concrete and it will deteriorate the concrete. If the chloride percentage more, what will happen? It will start reacting with the steel and the corrosion of the steel will happen. And if corrosion of the steel is happening, then what will happening? It will expand and the stress will generate and concrete will break. So that is why it is very much important to know what is the maximum limit of the water, because whenever we are adding water into the mix, the water start reacting. That is called the hydration of cement. And in the process of hydration of cement, if the sulfate percentage, if the chloride percentage, organic solid, inorganic solid, suspended matter is more, what will happen? It will also start reacting with the cement and it will produce not require as per the requirement of our concrete. The strength and durability will be a problem. That is why it is very much important to test the water whenever you are doing a mixed design. What you need to do, you need to take the sample from maybe the borewell or maybe from you are getting the water from the outside. You need to do the test of the water and all these parameter has to satisfy. Without the satisfaction of the parameter, you cannot do the make a trial or everything. Now there is always another point also given, the pH, because the water pH is important. Now the pH of the water is given shall not less than 6. Okay, it is a guidelines in the IS 456 in clause 5.4.2. It is given that the pH value shall not be less than 6. Why? If the pH value is less than 6, what will happen? It contains excessive amount of free acid, because less than 6 is the acidic medium. So this free acid will be there, organic matter and other impurities that can affect hydration of cement. So that is why it is saying it should be more than 6, and we already know that the pH of the concrete is to above 12. So if the pH of the water is going less, we will not achieve that much of pH for the concrete as well. So it will affect the strength development, it will affect in the cement hydration, and the durability also will be a problem. So that is why it is important to choose what is the pH of the water. In the site you can keep the pH meter, so whenever the water you are doing or concrete, you can check the pH immediately, instantly, no need to send to the laboratory. You need to keep a pH meter in your site laboratory so that you can check the water pH. If it is less than 6, do not use. Otherwise, if the concrete what you are producing, it will not be the as per the requirement, and the strength and durability will be a problem. Now seawater, we can use the concrete. It is given in the clause 5.4.3 also that the seawater, the mixing or curing of concrete with seawater is not recommended. So if you are working just by the sea, or so you can say that seawater we can take and seawater we can use for the concrete or the curing. No, it is recommended that it should not be used. Under unavoidable circumstances, seawater may be used for mixing or curing in plain concrete with no embedded steel. So that means it is given if it is the RCC, it is no way. It is not recommended that you can use the sea water, but for the PCC you can use, but do consider of possible disadvantage and precaution to be taken. Maybe you need to do some test, and you need to do some dosing for the water to neutralize the sulfated chloride or any other impurities, then you can use, but directly we cannot use the sea water. And what is the given that also that if you have a doubt on the strength development for the concrete after using the water from the source whatever, it is saying you can test the what cube for the compressive strength as well as the setting time as per clause 5.412 and 5.4.13. What is saying that if you have doubt, you can test average 28 days compressive strength of at least 350 concrete cubes prepared with water proposed to be used. So what water we want to use, that the proposed water we can make 3 cubes and shall not be less than 90% of the average strength of 3 similar concrete cube making use by the distilled water. So you can make the comparison. First you make the 3 cubes using the distilled water and 3 cubes make the proposed water, and if it is achieved more than 90% of the strength compared to distilled water cube, you can use. And another test you can also use with the setting time. The initial setting time of test block made with the appropriate cement and the water proposed used shall not be less than 30 minutes and shall not differ by plus minus 30 mm from the initial setting time of controlled test block use the distilled water. So the setting time also you can check whether it is the water whatever we are using or proposing for the water, it is actually giving us the test result or the durability or not by comparing the cubes made by distilled water and cube made by the water we are proposing. If it is in the 90% of the compressive strength, we can use, that is accepted. And if it is a setting time not less than 30 minutes and within the plus minus 30 minutes of the distilled water cube, then this cube also can be used. So these two tests also is given, this 5.4.12 and 5.4.13 of the IS 456. So whenever you are doing any concrete, this test also you can perform to find out whether the water you are using for the concrete is okay or not. Now these are all about the water for the concreting. Now another part is very important after the concrete is starting, that is the curing. That time also you are using water. So the curing water quality also has to be maintained. Otherwise, if it is not maintained properly, it is become a problem for us. So what is given the guidelines in the IS 456 in 5.4.4? It is given that water found satisfactory for mixing is also suitable for the curing of the concrete. So whatever the water we are proposing, if it is satisfactory, whatever all the details I have just mentioned to you as per IS 456, if it is satisfactory, then this curing water can be used for the curing. Now it is a common phenomenon that we are using the very good water for the concrete, but for the curing we can use any type of water, but that is also harmful. That is also affect the strength and the durability. So you need to check the quality for the curing water also for the same parameters. If it is satisfied, then only we can allow this water for the curing also. So however, water used for the curing should not produce any objectionable stain and unsightly deposit on the concrete surface. So that is also is given in the codal provision, that if it is produces unsatisfactory stain, then this water can also not be used for the curing. And the presence of tannic acid or iron compounds is objectionable. So that also you need to check for the curing water. If it is a tannic acid and the iron compound is there, it is not suitable for use to the concrete curing as well. So these are all about the water parameters for the concrete and the curing, and I hope you find it useful. And if you find it useful, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. And I am waiting for your valuable comment, so that from your valuable comment everybody will be benefited. And If you want to know anything more about quality control and construction, please let me know. I will come with more content like this. And thank you once again for watching me.